First question, a function is defined as f of x is equal to 1 if x is greater than or equal to 0 and minus 1 if x is less than 0 and n is greater than or equal to 3. Evaluate integral minus 1 to 1 integral part of x dx divided by integral part of x minus f of x plus n minus 1 divided by n plus integral part of x minus f of x plus n divided by n plus integral part of x minus f of x plus n plus 1 divided by n plus integral part of x minus f of x plus n plus 2 divided by n. It is given that f of x is 1 if x is greater than or equal to 0 and minus 1 if x is less than 0. For a given integer n greater than or equal to 3, we need to evaluate integral minus 1 to 1 integral part of x dx by integral part of x minus f of x plus n minus 1 by n plus integral part of x minus f of x plus n by n plus integral part of x minus f of x plus n plus 1 by n plus integral part of x minus f of x plus n plus 2 by n. In the very first look, this question looks to be complicated, but it is a very easy question. We have to integrate from minus 1 to 1 integral part of x dx. To talk about integral part of any number, we need to know between which two consecutive integers the number lies. So, integral part of x, when x lies between minus 1 to 0 is minus 1 and when it is varying from 0 to 1 it is 0. So, between 0 to 1 integral part of x will be 0. So, entire integral it will become 0. So, our contribution will only be from the integral minus 1 to 0. So, we have to evaluate integral minus 1 to 0 integral part of x divided by this quantity. What f of x is? It is minus 1 and integral part of x, because x lies between minus 1 and 0, integral part of x is minus 1. So, integral part of x can be replaced by minus sign. F of x is minus 1. So, minus f of x will be plus 1. Plus 1 minus 1 is just cancelled. We have integral part of x plus n divided by n. F of x is minus 1. So, minus f of x is plus 1. F of x is minus 1. So, minus f of x is plus 1. Plus 1 plus 1 is plus 2. F of x is minus 1. So, minus of minus 1 plus 2 is plus 3. Now, this is n by n is 1, 1, 1, 1. All n by n's we can bring them out of integral part and this integral becomes integral minus 1 to 0 minus dx by integral part of x by n plus integral part of x plus 1 by n plus integral part of x plus 2 by n plus integral part of x plus 3 by n plus all the 4 ones contribute to become 4. As x varies from minus 1 to 0, x by n is a number greater than or equal to 3, x by n will lie between minus 1 and 0. X by n will also lie between minus 1 and 0. So, integral part of x by n will be minus 1. This quantity will become minus 1. Now, when x lies between minus 1 and 0, x plus 1 will lie between 0 and 1. X plus 1 will lie between 0 and 1. And any number between 0 and 1 divided by an integer greater than or equal to 3 will also lie between 0 and 1. So, this integral part will become 0. X plus 2, x is varying from minus 1 to 0. So, x plus 2 will vary from 1 to 2. Any number between 1 to 2 divided by an integer greater than or equal to 3 will again lie between 0 and 1. So, this integral part is also 0 and with similar logic this is also 0. So, denominator you can see is a constant 4 minus 1 3. So, we have to evaluate integral minus 1 by 3 minus 1 to 0 dx, and this integral is 1. So, answer is minus 1 by 3, which is option 1. Next question, if integral minus pi by 4 to 3 pi by 4 e power pi by 4 dx divided by e power x plus e power pi by 4 into sin x plus cos x is equal to k times integral minus pi by 2 to pi by 2 secant x dx, then find the value of k. It is given in the question that integral minus pi by 4 to 3 pi by 4 e power pi by 4 dx divided by e power x plus e power pi by 4 into sin x plus cos x is equal to k times integral minus pi by 2 to pi by 2 secant x dx. We need to find the value of k. In this question, observe sum of 3 pi by 4 and minus pi by 4 is pi by 2. Sum of 3 pi by 4 and minus pi by 4 is pi by 2. This is a question on integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. We know the very important identity, integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx, and in this case a plus b is pi by 2. So, we can replace x with pi by 2 minus x. So, in this question replace x with pi by 2 minus x. This integral becomes integral minus pi by 4 to 3 pi by 4, replacing x with pi by 2 minus x, we have e power pi by 4 dx in the numerator divided by e power pi by 2 minus x plus e power pi by 4 into sin x plus cos x. This remains same because sin of pi by 2 minus x is cos x and cos of pi by 2 minus x is sin x, sum remains the same. Now, we can cancel one e power pi by 4 throughout. This becomes 1, pi by 2 minus pi by 4 is pi by 4, this pi by 4 also gets cancelled. Now, e power minus x can be written as 1 by e power x, take LCM, this 1 by e power x goes here, becomes e power x, and finally gets into the numerator and becomes e power x divided by e power pi by 4 plus e power x. Now, if I call this integral some I will also be equal to this. So, I, which is integral minus pi by 4 to 3 pi by 4 e power pi by 4 dx by e power pi x plus e power pi by 4 into sin x plus cos x is also same as integral minus pi by 4 to 3 pi by 4 e power x dx by e power pi by 4 plus e power x into sin x plus cos x. Now, this question is complicated in its first instance to evaluate the indefinite integral because we have a combination of exponential and trigonometric in the denominator. If by whatever means I can get rid of either exponential part or trigonometric part, then integration would become simple. So, for that what we will do is add these two integrals, add both the integrals, I is this much, I is this much, adding both of them 2I we get it to be upper limit and lower limit are both same, that is the reason we are able to add e power x plus e power pi by 4 sin x plus cos x, e power 4 pi by 4 plus e power x sin x plus cos x, denominators are both same. So, we can simply add the numerators and e power x plus e power pi by 4 gets cancelled with e power x plus e power pi by 4 and we will be simply left with 1 by sin x plus cos x dx. So, 2I it will be equal to adding both these integrals, denominators are same, adding up the numerators e power pi by 4 plus e power x gets cancelled with the factor in the denominator and we are left with a small integral 2I is equal to minus pi by 4 to 3 pi by 4 dx by sin x plus cos x. That is how this integral can get converted itself into a trigonometric integral. We have to write it in terms of integral minus pi by 2 to pi by 2 secant x dx. Now, this 2 we can take it to the other side, 1 by 2. Sin x plus cos x, in order to convert it into secant x, let me divide numerator and denominator by root 2. I am dividing denominator by root 2. So, if I divide numerator also by root 2, I have 1 by 2 root 2 dx by this quantity. It is cos of x into 1 by root 2, I can see it as cos pi by 4 plus sin x into sin pi by 4, which is cos of 1 by 2 root 2 dx by cos of x minus pi by 4. You can see the formula of cos a cos b plus sin a sin b, which is cos of a minus b. So, this becomes cos of x minus pi by 4 from the limits minus pi by 4 to 3 pi by 4, which is 1 by 2 root 2 into integral minus pi by 4 to 3 pi by 4 secant of x minus pi by 4 dx, secant of x minus pi by 4 dx. So, x minus pi by 4 we need to integrate when x is varying from minus pi by 4 to 3 pi by 4. This is as good as integrating secant x when x is varying from minus pi by 2 to pi by 2, or go for a substitution. X minus pi by 4 is equal to t. So, x minus pi by 4, if I call it t, this will be secant t, dx will be same as dt, and limits would be from minus pi by 2 to pi by 2. So, k, which is coefficient of the integral from minus pi by 2 to pi by 2 secant x dx, is nothing but 1 by 2 root 2. So, answer would be 1 by 2 root 2, which is option 3. Next question, suppose g of x satisfies g of x is equal to x plus integral 0 to 1 xy square plus yx square into g of y dy, then g of x is option A 180x by 119 plus 80x square by 119, option B x plus 7x square by 11, option C 180x by 61 plus 80x square by 119, and option 4 is none of this. It is given g of x satisfies the relation g of x is equal to x plus integral 0 to 1 xy square plus yx square into g of y dy. If we observe this expression carefully, g of x is equal to x plus, from this integral break it into two parts, x into integral 0 to 1 y square g of y dy plus x square into integral 0 to 1 y into g of y dy, y into g of y dy. Now, this entire quantity integral 0 to 1 y square gy dx is a constant, and also integral 0 to 1 y into g of y dy is another constant. So, g of x is x plus some a into x plus b into y, b into x square. G of x is a quadratic. Let me call this constant some a, and let me call this constant some b. G of x is equal to x plus a into x plus b into x square, which is a quadratic. So, b of x, g of x is a quadratic, bx square plus x plus 1 into a plus 1 into x. G of x is a quadratic, bx square plus a plus 1 into x. Now, to find the values of a and b, let us see what we assumed as a. This is our A and this is our B. Integral 0 to 1 y square into g of y. G of x is bx square plus a plus 1 into x. So, g of y will be by square plus a plus 1 into y dy. Or from this we have a is equal to by power 4, integral of y power 4 is y power 5 by 5, within limit 0 to 1 it is 1 by 5, b by 5 plus a plus 1 into integral of y cube, y square into y is y cube integral is y power 4 by 4, within limit 0 to 1 it is 1 by 4, a plus 1 by 4. Let me call this equation number 1. And similarly, the other constant b, it is integral 0 to 1 y into g of y, y into g of y, y into g of y is by square plus a plus 1 into y dy. This implies b is equal to integral of y cube is y power 4 by 4. From 0 to 1 it is 1 by 4. So, it is b by 4 plus integral of y square is y cube by 3. So, this is a plus 1 by 3. Let me call this equation number 2. Now, if we observe a and b, we have two equations, linear equations in terms of a and b. We have two linear equations in terms of a and b, and linear equations are very easy to solve for, and when you solve these equations you get the value of b to be 80 by 119 and the value of 1 plus a to be 180 by 119. So, g of x is 80 by 119 x square plus 180 by 119 x, which is option 1. Next question, the value of integral minus 1 to 0 x square plus 2x dx divided by log of x plus 1 is equal to option A log 2, option B log 4, option C log 3 and option D log 6. We are asked to evaluate integral minus 1 to 0 x square plus 2x divided by log of x plus 1. Log is in the denominator and in numerator we have a polynomial function, and this becomes a very difficult combination to integrate. So, let us see if any property of definite integral can help us out in doing this integration. Let me convert this with a substitution x plus 1 is equal to e power t. Let me go for a substitution. X plus 1 is equal to e power t. Integral log of x plus 1, log of e power t is t, dx on differentiation, this equation gives dx is equal to e power t dt, dx is e power t dt, x square plus 2x is x plus 1 whole square minus 1, x plus 1 whole square is e power 2t minus 1, or on multiplication with e power t, this becomes e power 3t minus e power t from limits when x is minus 1, x plus 1 is 0, e power t becomes 0 when t tends to minus infinite, and when x is 0, x plus 1 is 1 and e power t is 1 when t is 0. So, we have to evaluate integral minus t to 0 e power 3t minus e power t divided by t. Now, this is again a very difficult configuration to evaluate, e power t divided by t. So, instead what we do is plot the graph of the function e power t into e power 2t minus 1 divided by t. As x tends to as t tends to minus infinity, denominator is minus infinite, e power t is 0. So, any number close to 0 divided by infinitely large number tends to 0. So, e power t into e power 2t minus 1 divided by t tends to 0. It starts increasing, and as t tends to 0, we know e power t is 1, e power 0 is 1, and this is the standard limit, e power 2t minus 1 by t is 2. So, this function increases to become 2 when t is 0. So, if you look at the graph of the function, e power t into e power 2t minus 1 divided by t, when t varies from minus infinity to 0, it is a strictly increasing function having its values between 0 and 2. So, whatever be the area of the shaded region, that is integral minus infinity to 0 f of t dt, should be less than the area under this curve, and also it should be a positive number. So, let us look at the options. Log 2 is a negative number, it cannot be a possible answer for the question. Log 4 is more than 2, that is the value when we keep t constant to be function constant to be equal to 2. So, again option 2 cannot be the answer, and also option 4 cannot be the answer. So, answer has to be option 3, which is log 3. Next question, f of x is equal to integral 1 to x into x square minus 3x plus 2 dx, x lying between 1 to 4, then find the range of f of x. f of x is given to be integral 1 to x into x square minus 3x plus 2, and we are talking about x between 1 to 4. So, we need to talk about range of this function. To talk about range, let us look at monotonicity. Instead of finding the entire integral, let me directly find f dash of x. F dash of x by Newton-Leibniz theorem is derivative of the upper limit 1 into, substitute this limit here, x into x square minus 3x plus 2, we can factorize it as x minus 1 into x minus 2. So, if I start observing the nature of f dash of x, whether it is positive or negative, let us use wavy curve method, plot 0, 1 and 2 on the number line. If x is greater than 2, x minus 2, x minus 1, x are all positive. So, f dash of x will be positive from 2 to infinity, negative from 1 to 2, positive from 0 to 1, and negative when x is less than 0. So, using this, let me plot the graph of y is equal to f of x. F of 0 is integral 1 to 0 x cube minus 3x square plus 2x dx. Let us look at the value of f of 0. F of 0 is integral 1 to 0 x cube minus 3x square plus 2x dx, which is x power 4 by 4 is integral of x cube minus x cube plus x square from 1 to 0. Substitute the upper limit 0, that makes it 0. Substitute 1, minus 1 by 4 plus 1 minus 1, plus 1 minus 1 they get cancelled, and this is minus 1 by 4. So, f of 0 is minus 1 by 4. F of 0 is minus 1 by 4. And from here, because f dash is positive, f of x increases, and f of 1 is integral 1 to 1, a point integral, which makes it 0. And from here, function decreases to become f of 2. F of 2 is integral 1 to 2 x cube minus 3x square plus 2x, which is integral is x power 4 by 4 minus x cube plus x square from 1 to 2. Substitute 2 power 4 by 4 is 4 minus 8 plus 4, that makes it 0, and substituting 1 we get minus 1 by 4. So, f of 2 is also minus 1 by 4, and then the function increases, and at 4, because x is less than or equal to 4, at 4 functional value would be f of 4, which is integral 1 to 4 x cube minus 3x square plus 2x dx. Integral is x power 4 by 4 minus x cube plus x square within limits 1 to 4, and this on substitution of different values becomes 63 by 4. Substitute 4 here. 4 power 4 by 4 is 4 cube, 64, minus 4 cube is 64 plus 4 square is 16, 16 minus 1 by 4, that makes it 63 by 4. So, f of 4 is 63 by 4. So, we can see range of the function. Function is fluctuating between minus 1 by 4 to 63 by 4. So, range of the function is minus 1 by 4 to 63 by 4, which is option 1. Next question, the value of integral 0 to 1 tan inverse of 2x minus 1 divided by 1 plus x minus x square dx is equal to option A 1, B 0, C minus 1, D none of this. So, we need to evaluate integral 0 to 1 tan inverse of 2x minus 1 by 1 plus x minus x square dx. This is an interesting question. This 2x minus 1 we can see it as x plus x minus 1 divided by 1 plus x into 1 minus x dx, varying from 0 to 1. Now, if this x minus 1, I write it as x minus 1 minus x, x minus 1 minus x is 2x minus 1 divided by 1 plus x into 1 minus x. This is in the form tan inverse of a minus b divided by 1 plus ab. Tan inverse of a minus b divided by 1 plus ab. And x lies between 0 to 1 and 1 minus x also lies between 0 to 1. So, we can say this is formula for tan inverse a minus tan inverse b. Tan inverse of a minus b by 1 plus ab, we can write it as tan inverse a minus tan inverse b. So, this integral can be written as integral 0 to 1 tan inverse x dx minus integral 0 to 1 tan inverse of 1 minus x dx. Now, using the property that integral a to b f of x dx is same as integral a to b f of a plus b minus x dx, a plus b here is 1. So, integral 0 to 1 tan inverse x dx will be same as integral 0 to 1 tan inverse 1 minus x dx. So, these two they cancel each other and answer would be 0. So, answer is 0, which is option 2. Next question, integral pi by 4 to 3 pi by 4 phi d phi by 1 plus sin phi is equal to option A pi into root 2 plus 1, option B pi into root 2 minus 1, option C pi into 1 minus root 2, and option D pi by 2 into root 2 plus 1. So, we need to evaluate integral pi by 4 to 3 pi by 4 phi d phi by 1 plus sin phi. We have a combination of algebraic, phi is a linear function, 1 plus sin phi is a trigonometric function. So, we have a combination of linear and trigonometric function in ratio, so it is better we get rid of one of them. For that, simplest way is I, let this be the integral pi by 4 to 3 pi by 4 phi d phi by 1 plus sin phi. Now, pi by 4 plus 3 pi by 4 is pi, and sine of pi minus phi is sin phi itself, sine of pi minus theta is sin theta. So, denominator will not change when I replace phi with pi minus phi. So, let me use the property integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. Very important property, integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. So, I remains I even when I replace phi with a plus b, that is pi minus phi. So, this will become pi minus phi d phi divided by 1 plus sin pi minus phi is nothing but sin phi. Now, adding both the integrals, we can see denominators are same, upper limit and lower limit is same in both the integrals. So, numerators they get added up and phi and minus phi they get cancelled. So, 2i on addition 2i will be equal to, denominators are same, phi and minus phi they get cancelled, pi d phi divided by 1 plus sin phi. I can bring this pi out, 1 pi, let me divide by 2 throughout, I is equal to pi by 2 into integral pi by 4 to 3 pi by 4 1 by 1 plus sin phi d phi. Now, evaluation of this integral is simple, this is a standard integral. So, I will be pi by 2 into, to evaluate this integral we can follow various rules, one of which is I can write sin phi as cos pi by 2 minus phi, and 1 plus cos theta is 2 cos square theta. So, 1 plus sin phi can be written as 2 cos square pi by 4 minus phi by 2. 1 plus cos theta, sin theta I am writing it as cos of pi by 2 minus theta, and 1 plus cos theta will be 2 cos square theta by 2. So, pi by 2 by 2 pi by 4 minus phi by 2 d phi. Now, 1 by cos square is nothing but secant square. So, this cos square pi by 4 minus phi by 2 I can write it as secant square pi by 4 minus phi by 2, and this 2 can be brought out of the integral, makes it pi by 4. Integral of secant square theta, we know it is tan theta. Integral of secant square theta is tan theta. In place of theta we have pi by 4 minus phi by 2. So, this is a very simple integral to evaluate, integrate it, and we have the limits pi by 4 and 3 pi by 4, and small trigonometric manipulation gives you the answer, and the answer is pi into root 2 minus 1. So, answer comes out to pi into root 2 minus 1, which is option 2. Next question, if f of x is equal to determinant of x cos x e power x square, sin x x square sin square x, tan x 1 2, then the value of integral minus pi by 2 to pi by 2 f of x dx is, f of x is given to be a 3 by 3 determinant whose first column is x sin x tan x, second column is cos x x square 1, and third column is e power x square sin square x and 2. Now, we need to evaluate integral minus pi by 2 to pi by 2 f of x dx. Integral minus pi by 2 to pi by 2 f of x dx. Do not be in a rush to evaluate the determinant. We are asked for integral minus pi by 2 to pi by 2 f of x dx. So, if f of x is a odd function, this integral would be 0, integral minus a to a f of x dx, where f of x is a odd function is 0. If it is a even function, this will be integral 0 to pi by 2 into 2 times of integral 0 to pi by 2 f of x dx. So, let me check if the function is either an even function or odd function. We can see all elements in column 2 are even functions. Cos x is a even function, x square is a even function, every constant function is a even function. E power x square is a even function, sin square x is a even function, 2 is also a even function, and in the first column we can see all functions to be odd functions. X is a odd function, sin x is a odd function, and tan x is a odd function. If I visualize the evaluation of the determinant by first column, x into some combination of even functions, so I have a product of an odd function and an even function which makes it odd, minus sin x into some combination of even functions which is again an even function into odd function which is odd, tan x into combination of even functions which is again odd function into even function which is odd. So altogether we can say f of x is a odd function, f of x is a odd function, or we can even see f of minus x. F of minus x is minus x, minus sin x, minus tan x. Cos x remains cos x, x square 1, e power minus x square is e power x square, sin square x 2. So from first column if I take minus common, I will get f of minus x is equal to minus of f of x. So f of x is a odd function, that makes this integral directly 0. So answer is 0, which is option 1. Next question. Let y is equal to f of x be a continuous and differentiable curve. The normal set 1 comma f of 1, 2 comma f of 2 and 3 comma f of 3 make angles pi by 3, pi by 4 and pi by 6 with positive x axis respectively. Then the value of integral 1 to 2 f of x plus x into f dash of x dx plus integral 2 to 3 f dash of x into f double dash of x dx is equal to option A f of 2 plus f of 1 plus 1, option 2 2 into f of 2 plus minus f of 1 plus 1, option 3 f of 3 minus f of 2 plus 1, and option D none of this. So in this question we are asked to evaluate the value of this integral 1 to 2 f of x plus x into f dash x dx plus integral 2 to 3 f dash x into f double dash x dx, for which the given information is y is equal to f of x is a derivable curve and the inclination of normals at 1 comma f of 1, 2 comma f of 2 and 3 comma f of 3, inclination of normals are given to be pi by 3, pi by 4 and pi by 6 respectively. Tangent of these angles will become slope of the normals. So minus 1 by the slope of this will become derivative at that function point. So f dash of 1, which is tangent slope at 1 comma f of 1, will be minus 1 by tan pi by 3, and tan pi by 3 we know it is root 3. So minus 1 by root 3. Similarly f dash of 2, tangent slope at 2 will be minus 1 by slope of the normal. Slope of the normal is tan pi by 4 1. So f dash 2 is minus 1. And f dash 3 is minus 1 by slope of the normal, which is tan pi by 6 1 by root 3, that makes it minus root 3. So in the given question, by giving slopes of the inclination of the normals, it is given that f dash of 1 is minus 1 by root 3, f dash of 2 is minus 1, f dash of 3 is minus root 3. So let us see what will be value of this integral. It is given f dash of 1 is minus 1 by root 3, f dash of 2 is minus 1, f dash of 3 is minus root 3. Using this, let us evaluate this integral. Now f dash of x into f double dash of x, if I call this a function, I can see its derivative. So it is in the form f of x into f dash of x dx, which is f of x whole square by 2. So if I call this t, I can see dt, integral of t dt is t square by 2. So this quantity it will be f dash x whole square by 2 within limits 2 to 3, which will make it f dash 3 whole square by 2 minus f dash 2 whole square by 2 plus, let us observe, f of x plus x into f dash of x. This is a linear. F of x plus x into f dash of x. This is nothing but derivative of x into f of x. When I differentiate x into f of x, derivative would be first function f of x into derivative of x 1 plus x into derivative of f of x, which is f dash of x. So, f of x plus x into f dash of x is nothing but derivative of x into f of x. So, its integral will become x into f of x within limits 1 to 2 will make it 2 into f of 2, 2 into f of 2 minus 1 into f of 1, minus 1 into f of 1. So, this integral in value it is equal to 2 into f of 2 minus f of 1 plus f dash 3 whole square by 2 minus f dash 2 whole square by 2. To evaluate this, let us use the given information. F dash 3 is root 3 minus root 3. So, that will make it 3 by 2, and f dash 2 is minus 1, that will make this 1 by 2. 3 by 2 minus 1 by 2 is 1. So, this integral it is equal to 2f of 2 minus f of 1 plus 1. Answer is 2f of 2 minus f of 1 plus 1, which is option 2. Next question. Find the value of integral 0 to 2 pi mod cos x minus sin x dx. Option A 2 root 2, option B 2, option C 4 and option D 4 root 2. In this question, we need to evaluate integral 0 to 2 pi modulus of cos x minus sin x dx. For that, let us plot the graph of modulus of cos x minus sin x. Cos x minus sin x graph, cos x minus sin x when x equal to 0 becomes 1. At pi by 4 it is 0. At pi by 2 it is minus 1. At 3 pi by 4 it is minus root 2. Increases to become 0 at 5 pi by 4, and at 2 pi it is again 1. So, this is the graph of mod cos x minus sin x. Least value is minus root 2 when x is 3 pi by 4, becomes 0 when x is pi by 4 and 5 pi by 4, and at 0 it is 1 and at 2 pi again it is 1. But what we are bothered about is the graph of mod cos x minus sin x. So, when I apply mod, the part which is below x axis gets toppled and gets inverted, the graph becomes this way. The maximum value would be root 2 at 3 pi by 4, 1 at 0 and 2 pi, and becomes 0 at pi by 4 and 5 pi by 4. Now, integral 0 to 2 pi mod cos x minus dx is this particular area. So, we need to evaluate integral from 0 to pi by 4. 0 to pi by 4, cos x is more than sin x. So, mod cos x minus sin x is cos x minus sin x plus integral pi by 4 to 5 pi by 4. Pi by 4 to pi by 4 is 2 times integral from pi by 4 to 3 pi by 4. So, instead of evaluating from pi by 4 to 5 pi by 4, we can write 2 times integral from pi by 4 to 3 pi by 4, and between pi by 4 and 3 pi by 4 sin x is more than cos x. So, this integral is sin x minus cos x. And again from 5 pi by 4 to 2 pi, the area is same as this. These two areas are one and the same. So, again I can multiply by 2 here. So, all integrals are simple. Integral cos x from 0 to pi by 4, integral sin x from 0 to pi by 4, integral sin x from pi by 4 to 3 pi by 4, and integral cos x from pi by 4 to 3 pi by 4. So, evaluating these integrals, we get the answer to be 4 root 2. So, answer is 4 root 2, which is option D. Next question, evaluate integral 0 to pi by 2 dx by 1 plus e power root 2 cos of x plus pi by 4. Options, option A pi by 3, B pi by 4, C pi by 6, and D none of this. So, we need to evaluate integral 0 to pi by 2 dx by 1 plus e power root cos of x plus pi by 4. At the first instance, this question looks difficult, but it is a very easy question. Integral 0 to pi by 2, look at the formula of cos of x plus pi by 4. Cos of a plus b is cos a cos b minus sin a sin b. Cos of x plus pi by 4 is cos x minus sin x by root 2. Root 2 gets cancelled. So, this is e power cos x minus sin x. This cos x minus sin x, I can write it as e power cos x divided by e power sin x, which on taking LCM becomes e power sin x divided by e power sin x plus e power cos x. Now, this is visible to us in the standard form. If I call it f of x, pi by 2 minus x, sin of pi by 2 minus x gives us cos x. So, it is in the form f of x divided by f of x plus f of a plus b minus x integral a to b. Integral a to b, f of x divided by f of x plus f of a plus b minus x is a very standard result. Answer would be b minus a by 2, and it is in that same form 0 to pi by 2, sum is pi by 2 minus x, sin of pi by 2 minus x is cos x. So, if I call this f of x, this is f of a plus b minus x, f of x. So, answer would be b minus a by 2, which is pi by 4. Answer is pi by 4, which is option 2. Next question, integral minus pi by 4 to pi by 4 e power x into x sin x divided by e power 2x minus 1 dx is equal to option A 0, option B 2, option C E, and option D none of this. So, in this question, we are asked to evaluate integral minus pi by 2 to pi by 2 e power x into x sin x divided by e power 2x minus 1 dx. So, whenever it is in the form integral from minus a to a, if at all it comes out to be an odd function, we know integral is 0. So, let us check if it is an odd function. Let me divide numerator and denominator by e power x. This e power x goes down. E power 2x by e power x is e power x. 1 by e power x is e power minus x. X is an odd function. Sin x is an odd function. Their product is an even function. E power x minus e power minus x, it is in the form f of x minus f of minus x. So, when I replace x with minus x, e power minus x comes here, e power x goes there, which makes e power x minus e power minus x a odd function. So, this is odd function, numerator is even function, ratio would be a odd function. So, this integral, it is 0, answer is 0, which is answer 1. Next question, if s is equal to integral 0 to n modulus of product pi r equal to 1 to n x minus r divided by product pi r equal to 1 to n x minus r dx, where n is a odd integer, then the value of s is option A 1, B 0, C minus 1, D none of this. So, we need to evaluate the integral s is equal to integral 0 to n modulus of product of r equal to 1 to n into x minus r within mod divided by product of r equal to 1 to n x minus r dx. So, let us say this integral 0 to n, This product can be written as starting from r equal to 1, x minus 1 into x minus 2 into x minus 3 into so on up to x minus n, and in the numerator we have x minus 1 into x minus 2 into x minus 3 so on up to x minus n within mod dx. And here n is given to be odd, n is a odd number. Now, to understand mod x by x, we need to know whether x is positive or negative. If x is positive, mod x by x is 1. If x is negative, mod x by x is minus 1. So, in order to know that, we need to know the sign of the expression x minus 1 into x minus 2 into x minus 3 so on up to x minus n. For that, we have to use wavy curve method, plot the numbers 1, 2, 3 so on up to n on the number line. Now, whenever x is greater than n, x minus 1, x minus 2 so on up to x minus n are all positive. When x lies between n minus 1 and n, it is negative. N minus 2 and n minus 1, it is positive, and its alternate plus minus signs continues. N is a odd number. Whenever n is between an even number and an odd number, it is minus sign. An even number and an odd number, it is minus sign. And whenever n is between an odd number and an even number, it is a plus sign. So, this is the wavy curve nature of x minus 1 into x minus 2 into x minus 3 so on up to x minus n. So, when we are integrating from 0 to 1, f of x is negative, mod f of x by f of x will be minus 1, and integral 0 to 1 it will be minus 1 plus integral from 1 to 2, between 1 to 2 f of x is positive, mod f of x by f of x is 1, integral of 1 from 1 to 2 is 1 plus integral from 2 to 3 it is minus 1, integral from 3 to 2 it will be 3 to 4 it will be plus 1, so on. So, from 0 to 1, from 1 to 2, from 2 to 3, so on, every alternate interval we have minus 1 and plus 1. So, let us see how many minus 1s we have and how many plus 1s. From 0 to n, from 0 to n, we have n intervals, odd number of intervals, n intervals, of which in odd intervals alternate plus minus signs, odd number of them will be minus signs and even number of them will be plus signs. So, because we are starting it from minus 1, minus 1 plus 1 minus 1 plus 1 so on, we are going to end with minus 1 again, because we have odd number of numbers and alternately we are writing minus 1 and plus 1. So, we are starting with minus 1. So, we are also going to end with minus 1, and every alternate term they get cancelled and we will be left with minus 1. Answer is minus 1, which is option 3. Next question, integral 0 to pi by 2n dx by 1 plus cot n x power n, where n is a natural number. In this question, we can see cot n x, we can write it as cos n x by sin n x. So, this integral becomes integral 0 to pi by 2n cos n x power n by sin n x power n plus 1. When I take LCM, sin n x power n comes here, and this sin n x power n goes up to become sin n x power n divided by sin n x power n plus cos n x power n dx. Now, if you observe, if I call this function f of x, this as a, if I replace x with a minus x, that is pi by 2n minus x, we get sin of pi by 2 minus nx, which is cos nx. So, this will be f of a minus x, and this is already f of x. So, this integral, it is in the form integral 0 to a f of x divided by f of x plus f of a minus x, and for this we know the standard answer, it would be a minus 0 by 2 or pi by 2n divided by 2, which is pi by 4n. So, answer is pi by 4n, which is option 3. Next question, find the value of the integral a to b mod x by x dx, where a is less than 0 is less than b. Option A, b minus a. Option B, a minus b. Option C, a plus b. And option D, none of this. So, in this question, we are asked to evaluate integral a to b mod x dx by x, where a lies between 0, a less than 0 and 0 is less than b. To evaluate this, let us understand the function mod x by x. Mod x, if x is negative, is minus x by x is minus 1, and mod x if x is positive is plus 6, x by x is 1. So, let us break this integral from a to 0 and then from 0 to b. From a to 0, mod x is negative, so mod x is minus x, mod x by x is minus 1, plus from 0 to b, x is positive, so mod x is x, x by x is 1, so dx. Integral 1 dx is from 0 to b is b. Integral minus 1 dx from a to 0 is integral 1 dx from 0 to a, which will be a minus 0. So, answer is a plus b. Answer is a plus b, which is option C.